All right, I'm going to go a little fast because I'm recording it. You can look at this later on. But we got 15 minutes. I want to get through this. So let's read this. Okay, yeah, I'll have a real good, deep, bassy voice. It'll be good. Okay? So just note the wording here. The tide removes sand from Sandy Point Beach at a rate modeled by the function R. R of t equals this thing. Right away, we know that R of t is a derivative because it's the rate that sand is being removed. If we integrate R of t over an interval, it's going to tell me how much sand was removed. Everybody good? A pumping station adds sand back to the beach so everybody can still enjoy their summer at this rate, S of t. That's the rate that sand is added in. If we integrate S of t over an interval, it tells me how much sand has been brought back in. Make sense? Yeah? Garrett, you good? Okay. All right, so they're going to ask you multiple kinds of questions, gang. It could be how much sand was pumped back in, how much sand was taken away. Those are different questions. And they could also ask you how much sand is there now. Okay? But in order to do that, they have to tell me at least one time when we know how much sand there was. And they do that right in the very next question. Well, first off, they're given the units. They're measured in cubic yards per hour, which means the sand is measured in cubic yards. And at time 0, there were 2,500 cubic yards. Sound good? So look how easy this question is now that we know how to do all this junk. Question A says, how much sand will the tide remove during the 6-hour interval? What do we need to do? Show me. Integrate. Not both. Just R. Just R. From 0 to 6. That's it. And look, time out. Sometimes you just need to do the integral. That's how much change has happened. Sometimes you need to add in what it was originally. That's the amount. Pay attention to what they're asking. You're not adding in the initial amount here because they don't care about that. They just don't know how much left over that 6-hour interval, okay? So on your paper, you're going to write integral from 0 to 6 R of t dt equals. Okay? Anytime you do an integral on your calculator, you should you got to write it on the paper because you get points for writing out the integral. All right? So we're going to put in 2 plus 5 sine of 4 second pi t. The calculator is going to use x. It does not matter what letter it is. The calculator doesn't know what letters are. It's just using it as like a placeholder. All right, good? I'm going to quit out of here. And you can follow along with me and just pay attention. Or you can try to do it yourself, but we're going to go a little quick. We're going to hit map 9. We're going to integrate from 0 to 6. And we're going to integrate y1. So I'm going to vars, go over to function, y1, tell it dx. It's going to integrate it. And that is 31.816. Now remember, answers on here have to be accurate to 3 places, unless the question says round to the nearest whatever. Okay? You also need units on this. There's a lot of ways to not get full credit for this question. The units on this are, very good, cubic yards. It's okay? All right. Now, once you see a question like this on the AP test or in this class, and you know there's rates of change happening, you should be thinking in your head that there is an amount function. There's like an how much function, right? Sometimes they tell you just the rate of change, like I did for the warm-up. I just gave you f prime. Sometimes, more than likely, in your case, they're going to give you a rate in and a rate out. So let's think about this. If I had a bucket, there it is, look at that bucket, and I was dumping in 10 gallons a minute, but there was a hose at the bottom that was taking out 3 gallons per minute. What's the total rate of change of volume in that bucket? 7 gallons a minute. Positive, right? Okay. So B says write an expression for y of t, which is the total number of cubic yards of sand on the beach. Now, even if they did not ask me to do this, we would still have to do this part to answer the other questions, all right? We need an amount function. That's what this is. Before I write the amount function, let's write out what the derivative of the amount function is. What's y prime of t? What's the total change of sand on the beach? S of t minus r of t. Is that okay? It's the rate in minus the rate out. Okay? So right now you see we've got all these functions floating around here. Okay, so it's important to kind of understand what they're telling you for these questions. But if you read it, practice these. These are, again, probably one of the simpler kind of questions they can ask. All right. Now, that's not what they want. They want y of t. If we integrate y prime, which I'll write as s of t, you don't need to write the functions. You can write the letters. From 0 to any value, what's that going to tell me? Like, for instance, if I integrate from 0 to 8, that tells me the change in sand on the beach. It's not how much sand came in. It's not how much sand left. It's the total change, right? Because it's basically how much sand came in minus how much sand left, right? From 0 to 8. But that would not be the amount at 8. We'd have to add in what? The original, which was 2,500. The problem with this is that's the amount at 8. We just want the amount at any time t. So what should I integrate to? 0 to t. But if I integrate to t, that means we can't use these dumb things. Yep, we got to use x. And that is y of t. Make sense? In a lot of questions, they do not ask you to do this. This is not part of the question, but you still need to do it. Because they're going to ask you, what's the maximum amount of sand somewhere? What's the minimum amount of sand? You need this function. Yeah.
Will they take off points if you don't change to x on that?
They might. I will. So, you know, so yeah. If you're using t to integrate to t, then you have to use a different letter in there. Whatever you want. Again, usually you see x's and t's, but be any letter you want. Everybody good? That's B. C says, find the rate at which the total amount of sand on the beach is changing at time 4. How do you find out how fast something's changing? We check its what? Its derivative. So we want to know how fast the total amount of sand is changing. Well, the total amount of sand we're calling y of t. Y of t is the total amount of sand, right?
Yeah.
So the rate of change of it is just y prime of t. And it should also make sense. It's the rate in minus the rate out. So we need y prime at 4, which is really s of 4 minus r of 4. That's it. Well, we got to find the answer. Okay? So in my calculator, remember in y1, I've already put r of t. So in y2, I'm going to put s of t. And I'm going to remember which one's which. So that matters. I'm also going to remember when you put a fraction in, anytime the numerator or denominator has more than one thing, you got to put it in parentheses. So you can put that 15x in parentheses. You don't need to in this particular case because it's multiplication, but you've got to put the denominator in parentheses. If you're ever unsure, put the numerator in parentheses and the denominator in parentheses. So parentheses, 1 plus 3t. Boom. Everybody good? And then I need to know what's vars. I want y2 first, right? I want y2 of 4 minus vars y1 of 4. We get negative 1.909. And the units on that are cubic yards per hour. Feeling good? We almost got 10% on this test. So good.
Should we bother to say YDS cubed over hour?
You could write that, yeah. I'd like to write it out. I don't like yards cubed like that. It's weird. Okay. But everybody good? And now look at this. Ready? What time is there a minimum? We need to find the critical values. We need to find the amount of sand at those times and at the end points. Does that make sense? We need the critical values of what function? Well, there's no f of x here. Y of t. Yeah. We need the critical values of y of t, which means I need to know where y prime of t is 0. So this is weird. Currently, I have a graph. I have functions in. I have r and I have s in, right? I need the graph of y prime, which is s minus r. Cool. So I'm going to y1. Here we go. I'm going to y, and I'm going to make y3 y2. So I'm going to go into function y2 minus y1. And that's going to graph that derivative for me. Okay? Yeah, I don't want to see the other two, though. So I'm going to just go to the equal sign and hit enter on there so it doesn't graph them. Is that okay? And I only care about the window from 0 to 6. So I'm going to graph it from 0 to 6. So I'm going to go to window, 0 to 6. I'm not sure about what y should be. I'm going to leave it as negative 10 to 10 and just see what it looks like. Okay, you'll see that? It looks like there's maybe an intersection over there in between 0 and 1. You guys see that? So I might zoom in my y just to see this. Watch this. If you go to window and I make my y a lot smaller, negative 1 to 1, I'll be able to see if it hits it there or not, and it doesn't. Is that okay? So there's only one critical value. It's like 5 point something. We're going to find it. Second, trace, 0. I can see it's around 5, so I'm going to say look between 4, enter, 6, enter. I'm going to guess 5, enter. And we're getting 5.117 something. Right away, I'm going to store that letter as A. So I'm going to hit second, quit. I'm going to hit store alpha A. And that says store my answer as A, and that's that value we just found. On my paper, for question D, I'm going to write, I am solving for y prime of t equals 0. So I write that equation. I'm going to write t equals, and I'm going to write that whole number down. 5.117865. 7865253. And I'm going to call that A. Just like we just did before. Okay? The only new thing we had to do here was build our derivative off the rate in minus the rate out. But that's like the only trick they usually do to you. Sound good? Don't pack up yet. Here, kids, write this out with me. Here, we're going to finish this. Now that I found that, to find the absolute min, all I need to show is I'm checking the values at the endpoints and the critical values. So right underneath it here, I'm going to write y of 0 equals y of A equals y of 6 equals. So I'm going to find those real quick and then write a little sentence, okay? I'll drop this online. Was it 2,500? Plus math 9, 0 to alpha A of y3 dx. And we get, this is going to be the minimum, 2492.369. We knew y of 0 already was 2,500. And I'm going to do the same exact thing. Get my calculators back if you borrow one, please. But I'm going to change this to a 6 here, kids. This is going to be 2493.277. Then we're going to write a sentence. Here we go. What's up? After school? No. 369 cubic yards at time A hours. Oh, wait. Let's write what we did, right? That makes sense. I checked the endpoints and the zeros of y prime of t. The end.